Hello, everybody. Welcome to the Winning Routes webinar. We'll be starting momentarily. Just want to give folks about a minute to join in and get settled, and then we will begin. Thank you. Well, alrighty. We'll get going. So thank you all very much for joining today. Hopefully you are in the right spots. You are listening to Winning Routes, Optimizing Transmission and Interconnections to Reduce Conflict and Delay. My name is JJ Walter, and I am a Senior Client Success Specialist here at Pivot. I will be moderating today. Just a quick background, I've got 20 years experience, local government, nonprofit sector, commercial, geospatial, mapping, satellites, essentially a good smorgasbord of things, you name it. I've been doing it, but now my role is really to help our clients get the most value and be able to assist them out of working with Pivot. Right before I introduce Ben, who's going to be our conducting this webinar for us today, I do want to let you know that at the bottom of your Zoom screen, there is a Q&A. So if you have any questions, we will be doing questions at the end. Feel free to submit your questions there. I believe there's also a chat functionality if there's anything you need to let us know. And with that, I'd like to introduce Ben Browning, who is our National Client Development Manager. Ben actually kind of does a lovely crossover for us, both Pivot and Terracon. Ben has over 5 years experience in environmental and geospatial analysis, specialty in conducting routing studies, so perfect for today, and identifying environmental and engineering concerns for large-scale projects. His work has spanned more than 6,000 miles of corridor analyses and countless acres of land, supporting clients across the digital infrastructure, commercial development, power generation, and mitigation banking sectors. So he is a great person to be leading this webinar for us today. So I'm going to go ahead and hand it over to Ben. But again, should you have any questions, feel free to just submit it in that Q&A there at the bottom of your screen. Take it away, Ben.
Thank you, JJ. Hey, everybody. Like JJ said, I'm Ben Browning. I kind of work a flex position here. I'm the National Client Development Manager for Pivot, but I also work for Terracon and worked for Terracon for a number of years in the environmental sector, doing a lot of linear corridor alignment reviews and assisting in the routing of those linear corridors in all those different sectors that JJ talked about, like power generation and transmission. My specialty is the environmental sector, like I said, but I've collaborated closely through these routing methods with geotechnical experts and engineers as we work through all these different types of projects. And today I'm going to work through, a routing workflow that I've used to kind of, enhance the traditional workflow and provide my points of view on the challenges, constraints, and my perspective on how we can improve those using tools like Pivot. And we're going to try out a poll functionality today. So we have a test question. Is your team still in March Madness? And we'll see if this actually works. If it does, we'll have some additional poll questions.
Fun icebreaker. Yeah. So there you go. Hopefully you just had a pop-up on your window for answering that poll. And I am told the hosts and panelists cannot vote. So while you are submitting your votes, I will tell you that my team, the University of North Carolina Tar Heels, were knocked out by my niece's college, Virginia Commonwealth, VCU, in the first round. So no, my team's gone.
My team's gone as well. The University of Kentucky just got beat, and it was not a fun game to watch. So we're out for the season. All right. We've given it a couple of minutes. Maybe we can close the poll now. All right. Okay, now we can actually see the results. Nobody, the team is still in March Madness. Well, we could all be sad together. That's great to see. Well, I'm glad that the poll works, so we can take out our other polls as well, or we can use our other polls as well. Fantastic. Right. So I'm going to start with some of the challenges we see in the traditional routing workflows currently. What I have on the screen here is kind of walking through the 4 steps that we're going to discuss today. I'll talk about it a little bit more on the next slide as well. But some of the challenges that we see in routing today are shrinking project timelines. Everybody wants things faster. We need to find a way to be faster. Time is money. Any way you can shave off some time while staying, maintaining quality is very important. We'll talk about some ways today. One of the big time delays and problematic things I've seen in routing workflows is resources are compared in sequence rather than concurrently. So some examples of that would be assessing if we're going to utilize existing right-of-ways versus new corridors being established, identifying your stakeholders as well as their values and concerns. Same thing with your regulators. Identifying the terrain and land use constraints that you're going to have on these routes. Preliminarily what you're expecting versus what you actually find. And then once you actually hit the ground, generally you're going to find something else is inevitable. And then also assessing the environmental sensitivities in the area you're working, the actual resources on the ground and the values of the folks in those regions. Often people will work through these things sequentially in a different order depending on where they work and what their strategy is. And then we'll arrive with a problem in one of these steps that hampers the whole process and slows down their whole schedule. So being able to work on these things concurrently through your routing process is very important. Some examples I've dealt with as an environmental consultant, identifying streams too late, as in you thought the ditch that you saw on a map was not going to qualify as a jurisdictional stream. When it comes time to permitting, you learn that it is a stream. Same thing with wetlands, not identifying wetlands too early in the routing process along where you're installing poles. Permitting impacts and consultation for stream and wetlands can range from 3 to 18 months of permitting time, can require redesigns, and often come with mitigation costs as well. Another example I've dealt with personally are endangered species reviews and habitat assessments. Variety of species across the country. Every state has their own lists as well with their own unique regulations. And a lot of these endangered species have particular ranges for surveys. So, for example, bats have a very specific range where you can do assessments for their presence or absence. And you have to just wait till that time of year where you can do those assessments. So identifying it really early on is important so you know to get the right consultants for that kind of work. So just re-emphasizing why it's good to identify all these things concurrently because a lot of these things take a long time to permit and work through. Some other challenges that we've seen is increased scrutiny and more organization between landowners, environmental groups, and regulators. So it's really important to be able to visualize, quantify, and show your work to regulators, landowners, and stakeholders to best communicate how you've ended up where you are. Like, how did we determine this is our best case route, and how are we addressing all of the issues that arise? And understanding what constraints and environmental resources we're going to hit early and coming to the table and explaining those to folks really can build trust, and building trust can make sure that this process moves smoothly. We're going to try our poll again. And we have another question about, JJ, you go ahead.
Well, I was just going to say, yeah. So as we're talking about constraints, we're just curious, what has been your biggest constraint recently? So we have a quick poll, Rachel, if you want to launch that. Yeah, feel free to just kind of put a quick response in there. Leave that open for a few seconds. Shouldn't take too much time. All right, Rachel, I think you could probably go ahead and close it now. It's a pretty quick thing. I believe once you close it, we can see, there we go.
So shortened timelines, very common, kind of what I expected. I'm curious if you have something else that you want to talk about. I'd love for you to send it in the Q&A, and we can address those problems as well. I can talk about my personal experience at the end with those. But that's very nice to see. Thank you all. So jumping further into the process. So like we saw in the last slide, we've broken it down into 4 steps. Our first step is going to be identifying our prospective area. Then we're going to talk about configuring our constraints and different ways we can do that. Then how we can generate routes as well, the different options we have there. And finally, how are we going to assess all these impacts that we find through this whole process, and the different ways we can visualize, quantify that information. And finally, we start the whole process over and do another iteration. Generally, the first iteration is not perfect, and we're going to have to make some fine-tuned adjustments. It's just a part of routing. So we'll start with identifying our prospective area. This is, where am I trying to go? What is our point A to point B, or A, B, C, D, E, F, G? Like, how many points are we needing to connect? And generally, the most cost-effective method, if it's possible, is as the crow flies, straight. Can we do, our best case would be our straight line. Within pivot, our prospective area is called our objective path. And this is what we're going to use to connect the locations that are our start and end point, our final goals. If we have multiple options of beginning and end points, we can generate multiple objective paths as well and generate our routes and go through this whole process for each one of those. While we identify the start and end points, it's also really important to identify areas we absolutely do not want to go. These we call our exclusion areas. These could be a variety of different items. This could be Farmer Joe that really does not like the project that we're trying to install, persnickety landowners that we already know are going to be problematic, either from past experience or previous stakeholder engagements. It could be particular towns, cities, or even counties where they may have very restrictive regulations or current issues regarding their active regulations. Maybe we want to avoid those as best we can. And then it's really important that we continue to note and add additional exclusion areas in future iterations. Usually when we work through this process, we'll find other areas that end up being problematic, or our stakeholders will help us identify areas they really don't want to see impacted. So once we've established our objective areas, we need to configure our constraints. So there are a lot of different data sources and kinds of constraints that we could consider. This is just a list of all the ones that we can host in our Pivot platform. We can add other ones to look at as well. These are the ones that we have standardized. Each one of these lines doesn't necessarily mean a single data source. A lot of these are an amalgamation of several data sets. And it's kind of overwhelming when you look at all these different options that we have. And a manageable way to configure constraints is to establish a weight of importance for each constraint. We can do this in Pivot. This is the way I generally do it, using an algorithm. We call our algorithm a PLAE, and the acronym stands for Prefer, Low Avoidance, Avoidance, and Exclusion, as you can see on these sliding bars. What we can do is look at all the different data sets we have and even break it down into subtypes and quantify on the sliding scale how important it is to prefer it, avoid it in some capacity, or exclude it. And we can put an offset on it as well if we really, really want to stay away from it. The example I have on the screen is one of our grab bag layers called land ownership potential conflict. And it's just pulling all of the additional problematic areas that people may forget about when they're doing kinds of routing studies, but are still very important to consider. Some of the big ones I've dealt with before are cemeteries that can be very problematic. I usually like to put an offset on cemeteries because there could be bodies outside of the fence. It's happened before, it happens pretty often. Agricultural easements and especially conservation easements are some odd items. And this could really vary from county to county, state to state. But we can assess and provide a weight for every single resource that we have, or we can pick and choose which resources we want to consider in a current iteration. We may make multiple PLAEs to run at the same time and compare. An example would be building a PLAE to minimize floodplain impacts. Maybe we don't want to disrupt the floodplain, get any floodplain permits. But then while we're working through that, we identify either through our stakeholders or maybe someone addressing our scope that we also need to avoid conservation easements. Well, we can go about configuring these constraints by making a PLAE hyper-focused on total exclusion of floodplains. Then we can make a second one where we totally exclude conservation easements and ignore floodplains. And finally, we can make a third PLAE where we totally exclude both. And then when we get to the next step, generate all of them and see if we have radically different adjustments to our route. And we can do this for all of our different resources that we find need to be addressed. We can do a PLAE where we code all of them in there simultaneously. We have a lot of options. The final piece when you're configuring your constraints that's really important, and we've mentioned before, is are we going to co-locate on existing right-of-ways? Do we want to use existing utility routes? That can often be a really beneficial way to route, but it's also important to establish if there's required offsets against those utility right-of-ways. There's areas in the US where you need to be offset a certain distance from those lines, and I'm able to code that in when I'm working within Pivot in my routing studies. On my picture here, you can see that we can use power lines, but we can use other forms of right-of-ways. We can run along transportation routes as well, and pipelines and such and so forth. And so it's really helpful to run a potential PLAE with a co-location and without, to have a greenfield route as well. I really like to do that to compare. Often, if you're going to co-locate on existing right-of-ways, it could lead to a longer route, additional material costs. So having those two options to weigh side by side is very helpful. JJ, is this our next poll question or is it on the following slide? I apologize.
I believe it's a little bit after the next slide.
Okay, yes. Yeah, it would be this one. So after we configure our constraints, we're going to move into route generation. So we have a number of different ways we can generate routes. We can go old-fashioned and we could hand draw a route, on pen and paper. We could also hand draw them within our applications. Pivot, we can also hand draw in and just overlay all the data sources that we care about and painstakingly draw those in. That's going to be a high level of effort, but it's an option. And a lot of folks with a lot of experience really like to be able to, tweak things themselves. We can upload known routes that have already been established or routes that someone has provided us, maybe a third-party entity, or routes that were created in previous studies. Then we can finally use our PLAE or the algorithms we're using to generate our routes as well. And it's really important that you can compare all of these different methods if you're using them in one platform or in one location, so you can compare them side by side and assess impacts in a similar methodology. So now it's time for our poll question. So how have you generated routes in the past? I'm very curious to see if people have ever used the Pivot PLAE or another algorithm. Or are you guys just, everyone on here, uploading routes that his design teams handed you, or have you gone through the painstaking process of drawing them yourself? I think that's enough time, Rachel. Let's see what our results look like. Okay, not many people have worked with algorithms. That's really interesting, mostly pulling from other design teams. Well, I hope working through this will help people understand the value of using an algorithm like the PLAE to generate your own routes. And often it can be really helpful on a lot of these studies. I've been handed routes that have been generated by a different design team, and we hit a problematic area. Some of the classics are buried lines through cemeteries. And then generate just from point A to point B beyond the cemetery to show potential reroutes for that section of a corridor that's being developed. So instead of just coming back to my design team and saying, hey, this is very problematic, I can recommend other directions that we could go to reach our final destination, maybe just for that small subsection. So once we have generated our routes, now we get to the fun, tedious task of assessing all of our impacts. What are the impacts and risks for each route that we've generated? How can we compare all of these? And then how do we communicate all these comparisons and their importance? So we have a lot of options of outputs that we can use, and that's really important. One type of output may not cut it. I'm going to run through a kind of long example of just me doing this myself and why it's important to have all of these options. One thing that pretty much every routing study requires is to assess all the parcels and stakeholders that we're going to intersect. So one big piece of this process is always looking at our parcel maps, seeing who we're crossing, how much land we're crossing, so we can estimate our right-of-way costs. What I would do in this case is I would jump into my Pivot software, and the far left image here is what it looks like operating within the software to compare each individual route. I can pull that up and compare all the routes to count out. It'll surmise the number of parcels that are being crossed for that particular route, so I can assess which one's going to be the least number of landowners. So once I've done that, I can then download an Excel detailed constraints report, like in the second image here, that will have all this information in an Excel spreadsheet that I can go churn through and do some good data analysis. Generally, that involves me pulling out of that all of the acreages that are being impacted, because our system will calculate, if I say, hey, all of the routes I'm generating, I'm going to have a 300-foot wide buffer on it, or whatever, it will calculate the total acreages intersected for that particular parcel. So I can identify which parcels I'm going through and how much land in acreage in acres that I'm impacting for that particular landowner. Often, multiple parcels will be owned by the same entity. The system can pick that up, and we can merge those together as well to then further break down, how many acres for a particular stakeholder as well. That's all very helpful information, and we can take that and compare it to market studies that I may pay for or have had collected in the past. Maybe a previous part of the study or of the project had a market study, but I've run into this problem before. I've collected all this great data, but the market study goes a little more detailed than what I've collected so far. It may have particular land costs based off of distance to a highway or distance to a road or distance to water bodies. Often that land's more expensive, and the market study will notice that. Well, now I need to do some more geospatial analysis. I can download a KMZ or a file geodatabase of my data, hand it to my GIS team that can do some good geospatial analysis to ID, hey, what parcels actually have these rivers and highways crossing them? We have all that data in here to calculate that information, break it down to match our market study. Now, when we get to actually contacting our landowners, if we like these routes, they often want to see where we're going to cross their land. We can use, in Pivot at least, an output to create a KMZ of all these potential routes, hand those to my GIS team or create the figures myself, overlaying those KMZs like into another software that they can easily access to identify where these routes are actually crossing on their properties. And help communicate those very visually for those people. It's also very helpful when my field team comes to me and they want to help assess, can they safely access these locations to continue this study for feasibility. Often we want to send geotechnical rigs out to areas to assess slope stability and how we're going to have to drill and install these poles. So we can output geospatial files, like I've said before. One option that we've often done is elevation profiles. So we can download our elevation data, pull that into another software, and create a profile like in the far right image here to see where slope stability issues may be a risk, as well as is it feasible to actually access these areas with the traditional geotech rig? Do we need to get some specialty equipment out here and help guide our field teams to do like the fastest, safest, and most cost-effective field studies as well. So we've communicated all this great data to our team, the landowner, and unfortunately often we decide this isn't going to work out for a particular parcel. Well, maybe my team really does like the route that I've generated, but this Farmer Joe just is not going to let us work on their land. Well, we can go and generate a suitability corridor, like in this third image here, that shows us other potential routes of least cost based off the PLAE we've generated. So blue is showing us areas that would be recommended to go, that would be a suitable alternative. Greens are kind of middling in that range. And then as we move to yellows, orange, red, and then white, those are areas that are not going to be very good. They're going to impact a lot of these constraints that we've been discussing and prioritizing. The suitability corridor is also taking distance into effect. So it's not going to recommend some wildly long route as a primary one. So we can see in this image here, the eastern section of our corridor actually may be a pretty good option. If length isn't going to be a concern, there must not be a lot of impacts for the PLAE we designed. But having a visual tool to be able to do that is really helpful. We can provide that to our design teams and our field crews as well, to continue this estimation of where we want to put our lines, see if we're going to hit the same landowner on some of these potential alternatives, or do we need to go back to the cutting board, generate a new PLAE, maybe use a new objective path. So we've run through our 4 steps. Like I said at the beginning, the first version is rarely the final version. Often we have to go back to square one and adjust some items. We may adjust our objective path. Maybe we want to try some different start and end points. We've probably identified some new exclusion areas, potential parcels, landowners that we want to avoid. Maybe we found some additional easements and we need to boost some ranges on those easements. They weren't exactly correct. Or maybe we have sent out field crews and they've identified additional wetlands that weren't on the federal registrar. We can use exclusion areas to avoid those. We also may want to adjust that PLAE. We probably do. We want to make some new adjustments, try some different constraints, and regenerate our routes. Often, your scope may change, your priorities may change as we roll through these transmission projects, especially with changes in regulations. And finally, we want to show our work well. We want to keep this whole history of types of routes we've chosen, our different objective paths. Being able to show your work is really important to landowners, to your team, and especially to regulators, because they want to understand why you're going through an area, why you may be impacting resources that need permitted, and being able to show that you've assessed and looked and compared to other routes can be really effective ways to get your permits moving quickly. Showing your work, showing this isn't your first choice, or this wasn't your first test, you've actually assessed several different options can be very helpful. And being able to output this stuff into usable formats, like I've talked about. Everyone may have different preferences. Some folks may want to quantify exact acreages using a spreadsheet. Others may just want a pretty picture that they can look at to identify where it's going to go. Being able to provide all those options to your team and your stakeholders is really important. So now we can jump into some questions if we've generated any. JJ, do you have anything to add?
I do actually. I'm going to steal the share really quick and just kind of post a page here. Oh, give me 1 second. Come on, screens. Too many screens. So I think Ben has done an awesome job at pulling all this together. And so I just kind of want to take a moment to kind of recap as well and stress that, whether you are working with pivots or whether you were doing this all on your own in whatever software, whatever it is you are using, this process that we are showing is generally going to be the same. I mean, it sounded like from the one poll that a lot of you are utilizing routes that are being given to you by somebody else. So, the prospective area is effectively given to you, but you still need to configure the constraints. You still need to understand what's going to be happening there. So again, whether you're using us, somebody else, you want to pull in all those data layers to what Ben had said. So, all the information you need to pull in so that you can kind of organize against that route to understand, what's happening along that route. Even if you're given a route, you might then make those adjustments, as Ben was stating, so that, if you see a certain constraint, if you see that you've been given a route that maybe was going too close to a cemetery, too close to a wetland or something like that, then you're still going to be altering those routes, then ultimately producing something that you can then give back, show to your colleagues, show to the regulators, show to the client or whomever's giving you that route, right? So these processes are always going to be the same. It's just a matter of how can you best do so. Um, and ideally, most easily uh, do so. So I do want to stress that, obviously a lot of the examples we use is because of the information that we have available to us, but you're still going to need to socialize whatever it is you have, be able to make it defensible, be able to explain why you decided to go a particular route that you did, and back that up or decide why out of 5 different route options you chose route number 3. So as you can see, there has been explained, being able to compare the routes, being able to pull like what's happening on each of those routes. So like what's crossing, what's the constraints for each of those, and then how do you visualize it? Just kind of quick examples. Um, ah, Sharing window has stopped. I didn't want to stop sharing.
No, I'm sorry, did I mess it up? I'm sharing the
I don't
same
think
screen, I
you
think.
did, so I can go over it here. But just as a quick example, again, within whether it's ArcGIS, us, you're creating a map to be able to show what those routes are, right? So you need to visually be able to explain to people, here's the 2 routes. I created one route using our play or the algorithm, however you call it, and then maybe a different one that was co-located to right of way. So you already have 2 options. And then once you have those, you start looking at different types of comparisons to see how you're going to decide between those two, or types of going down through uh, different data layers to understand kind of what exists and how you're going to be able to explain that to people. So again, you could do this in Google Earth, right? Same routes. And now you have their information where you're able to upload different routes and be able to finish. So that's always going to be the case. You're always going to, at some level, need to show people how different data is impacting your particular routes. Um, and as Ben pointed out, not only can you see how these impact along the mile markers of different routes, but you can often see the amounts that it's crossing with your buffer. You can see the acres impacted. And again, these are all the things that whether using us, whether using somebody else, you are going to need to convey that and socialize that to other people. So I just want to stress that, this is, the process. It's kind of that we would recommend then based on Ben's experiences, based on other similar experiences. Um, you know, so just kind of want to reinforce that. And then, yeah, now we'll take some questions as well. I want to read one here as I go through. Um, Ben, what have you seen as like specific examples of you mentioned at one point a project gone wrong, or that they didn't know. I think you mentioned wetlands or something like that. Like what are the impacts? How does that what happens when you find out these things later?
Absolutely. So, one example, I think I mentioned ditches people think don't count as jurisdictional streams. As federal regulations change, often state regulations change with them, but often they do not as well. States can have their own regulations. Uh, we had a project where we were crossing a ditch and a pole was going to go right beside the ditch that turned out to be a jurisdictional stream and still qualified following the state and the federal regulations for jurisdictional streams. We ended up being delayed about 3 months because we had to go through the permitting process, even though we didn't end up having to pay any mitigation costs because we moved the pole out of the way in the end. We didn't identify this at the beginning of the routing process. We were already going to construction to install the poles. We had gone to get our construction permits, the client we were working with, and then they got denied those construction permits when the government saw that it was a blue line stream, as they refer to it. So it was a blue line on a map when you look at a topographic map, which triggered them to consider it for jurisdictionality. That's when when I got involved and we had to start the whole painful process of impact permitting. Now, if they had gone through and assessed all of these data sources, saw that it was going to pop up on the federal listings as a potential stream, we could have caught it early, started that impact mitigation, assessed it with the government early, probably built some more trust as well, showing them that we did our homework before we showed up on site. Or we could have just redesigned and moved the pole somewhere else and dodged this whole headache before we sent rigs out to install. So we ended up with, I think, 3 months of permitting effort, a lot more time of wasted sending crews out that we had to send home, send them somewhere else to build, and then come back and build it anyways. Many, many days of MOB and demob costs and the permitting process as well. So a lot of money and time that could have been spent elsewhere if we had just done a more due diligent review like this.
Interesting. Thank you. And I also, again, want to remind people, if you have additional questions, if there's any particular use case or anything that you would like for Ben to address directly, feel free to just go ahead and put it into either the chat or the Q&A, and we can respond directly that way because I don't believe we have it set up so that there is communication and to everybody from the users.
And if you don't have questions right now, I mean, we have our contact information on the previous slide. Please reach out to me or JJ if you guys have any additional questions. Often people come up with them later. You can also reach out to us through our Pivot website and using the contact us form as well if you have any questions.
1 second as I come on screens, get out of the way. So one question is, what have you found like as again either when I'm reading it, the larger constraints, like the most impact, like what has been typically constraints, or are there specific constraints that are most impactful, most concerning, or is it kind of more general across the board depending on the area?
I think a fun one that can vary incredibly state to state is cultural regulations, working with different SHPO offices. That's the State Historic Preservation Office. All of them have a different name for every state you go to. A lot of them take transmission projects in particular at a different degree of scrutiny. I've had ones where we are not installing any new poles, but we're just stringing a singular line, very far away from a historic and National Register of Historic Place registered site. And we still have to go through a cultural assessment to approve that new line being stretched across the pole. Other areas, it's not a big deal at all. That's probably a big one that happens a lot is cultural resources. If you're crossing a historic district, if you're working anywhere near, so the NRHP, National Register of Historic Places, we have that data layer in Pivot, but that's just a primer. Looking at your cultural resources in an area, even when you think it's not going to be a big impact, can often be a very scrutinized section of the process. So once you have a particular area that you're going to route. If you're going near historic structures, old barns, historic districts, towns, those are areas that I would definitely pay a lot of attention to. Cemeteries as well. I've had ones where we're stringing line over a cemetery. Our poles are several hundred feet from the boundaries already established. We still have to go through cultural consultations to go over those cemeteries, even if there's lines already strung across them over those. So lots of good considerations, lots of early contact efforts I would highly recommend on that front when you're going through routing. And if you identify a very a large area that is listed as a national historic location, getting started ASAP. See what those regulations are going to look like at that particular location.
Awesome. Thank you. Um, so another question, are we all working on any AI tools to integrate into Pivot in terms of creating optimal routes? Is one question. How many iterations should it take to get to a quality route using the play, the algorithm?
So we can start with the first question on there that was about AI tools, correct?
Correct.
So we are working on it currently. Our tools currently do not have any AI. I don't know how the integration. And AI is not integrated into our PLAE algorithms currently. And then on the section about how many iterations, it truly depends on where we're working, the length of our route, and I mean, it's such a vague answer, but it's just situational. I have had areas where we're only running, like 10 miles, and it's going to be very non-problematic through a lot of different ag fields, and we make it really easy. I had one that we just did recently where we're going through the Midwest, and we hit a bunch of center point irrigation systems. So those are those perfect circles you see when you're in an airplane, and those center point irrigation systems are incredibly expensive to move. Well, we had to go and route around every single one of those circles. So even though we're going through ag fields, it was a lot of rerouting to avoid those areas, a lot of exclusion zones we had to develop. So it kind of just depends when we hit up, especially when you're going into urbanized areas where you're going to need to do some additional PLAE tweaking when you're just getting a higher density of potential resources. And then, I mean, truly sometimes, using an algorithm to get you 90% of the way there can be really helpful. Like Brandon said here, a lot of people end up digitally manually moving around some of their bits in the end. And I think that's totally fine. My method is often, let's start big. Let's do the easiest thing, the fastest thing at the largest scale. Let's see if we can get a fairly optimal route. And then when we have those problematic touch points, maybe between a couple of mile subposts, that's when we can get in there and manually redraw those particular locations. So sometimes using all of these different methods together can make the most optimal route, starting with our algorithms and then working our way down to some manual redraws of particular locations.
Yeah, and I want to add on to the AI portion of the question as well to say that just to reiterate that we are working to integrate, but some of the things that we do want to make sure of is that you're not getting a lot of those kind of false results. We are going to be focused on making sure that our data is as strong as possible so that the AI reading all of our data sets, it's essentially using the most trusted sources so we can point it there. So we are kind of working on those best practices to do so. We just don't want to do so too quickly and kind of sell something that sounds good, but isn't, may not functionally necessarily be good. So we are doing a lot of work in that vein. We just haven't really released anything to date in that vein yet. Ben, any parting thoughts, suggestions, or anything before we wrap up here?
No, I don't have any other notes I think to add other than please reach out to me or JJ if you guys have any other questions about routing or if its capabilities to assist in routing or any good use case examples of times that I love to hear when people have big hiccups in their projects, what that project hiccup was and what you could have done to avoid it in the first place.
Yeah. So thank you all very much for your time. Yeah, to reiterate that as well, we're always happy to jump on additional conversations or additional calls, have additional conversations. Um, I know there are a number of folks who are already working with Pivot. They're attending this webinar, and that's what the client success team, so myself and Tara, are here for. So by all means, use us, reach out to us. We can always jump on to help work through any workflows, kind of best practices, things like that. And as you can see that we have great people like Ben to turn to, who has been doing this work as well. So he can definitely commiserate and has lots of examples and best practices to share. So thank you very much, Ben. Thank you very much to everybody who took their lunch hour to join with us. Hopefully this was very useful for you. And yeah, look forward to more webinars coming soon.
Thank you, JJ. Y'all have a great day.
Thank you all very much. Have a wonderful afternoon.